Am I audible? Okay, so I hope all of you have watched lectures of week 1, 2, 3, right? You can unmute yourself and like say if you want to ask anything.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So one just like if you unmute yourself, just make sure to mute after that. Okay. Once you are done with your query. Okay. So am I audible clearly? Are all of you guys able to hear me loudly?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Okay. Okay. So today we'll do week 3. Right. Before that, I want to bring something into your attention. Just give me a moment. Let me open that screen. That is the discussion forum. Okay, I have observed that like none of you guys are using the discussion forum in case you are having any doubts and all. Because this discussion forum is like a Google group, right? Where you can go and ask your doubt. Just give me a moment. I am finding the link of that forum.
அவங்க அப்ரூவ் பண்ணல இன்னும் அதிகமா பாக்கணும்
Mute
கண்ட்ரோல்
yourself if
பண்ணல
you are not using your mic. Okay.
அவங்க அப்ரூவ் பண்ணல
Okay. So I hope my screen is visible, right? Yeah, here it is. So the discussion forum that I was talking about, if my screen is visible, like if we go to like the portal, right? This is the portal for this term, right? So up to I guess week 4 is released for all of you, right? So now if you go to the portal, here you see in that corner, it is discussion forum is there. Once you click with, and you should be logged in with the mail ID where with the one which you have registered. Okay, then only you will be able to access that. For example, this one, right? So can you see there? You can just go and start a new conversation, and like you can ask the doubt that you have heading, and then the body of that one, right? For example, some of the student have asked, like for example, this is the heading, right? In the section last video, there is like some doubt, and then this is the body. So that's how you can like let's say in some lecture you are facing some issues or not able to understand, let's say what is k-means clustering, not able to understand or something, you can just go to this forum and ask your question, and me and Prashasti, that is the another ts, she will join the take the session next week. At least both of us will try to answer, and in the meantime if any one of your classmates also answer, that's fine. Like we can verify that, and we can like acknowledge that yeah, this explanation is fine or this definition is correct. You can go ahead with the understanding. Is this fine with everyone?
Yes, sir.
Okay.
Yes, sir.
Someone have raised his their hand. I want to ask something. Let's see.
Sir, I have a doubt, sir.
Yeah, ask.
Is the practice assignment compulsory to submit or
No,
it's
that's
just
just for your practice purpose. That even if you do it, that's fine. Even if you don't do it, that's also fine.
yes, sir.
Okay.
Yes, sir. Thank you.
Let's get back to our today's topic. What we are supposed to do. Yeah. Week 3. I hope my screen is visible to all of you.
Yes, sir.
Yes, sir.
Yeah. So just go to again this www.menti.com and then enter the code 69169136, or you can directly use the keyword to join this.
फ्रेंड
Okay.
क्लास लेना
So those
எங்கிருந்து யாருன்னே தெரியாதுண்ணா
please mute yourself.
யாருன்னே தெரியாது
Okay, I think almost 70 people are present in this meeting and 22 have joined. Those who have not joined, please join as soon as possible. Within 1 minute, we'll start with the topics of the question that we want to discuss. www.menti.com and this code 69169136. Okay, so let's start. This term, I guess you have encountered in the lecture, paradigms of learning, right? What actually is paradigm of learning? So in the previous sessions, we have talked about supervised learning, unsupervised learning, and then sequential learning, or maybe reinforcement learning. This term, are you guys aware of it? Like, not the meaning, but have you heard it in the previous session or in the lectures? This term, supervised, unsupervised, and maybe reinforcement learning?
Yes, sir.
Yeah. So today we'll actually discuss. First 2 weeks was actually data preparation, like getting yourself hands-on with the collection of data and hands-on with the Google Sheet, right? How to load the data, how to collect the data. That's it. Now, once you have load the data, collected the data, clean the data, get some meaningful insights from the data. Now we have to go towards predictive modeling, right? So for predictive modeling, we need machine learning, and then there comes the paradigms of learning, like what's the different types of learning that we have inside machine learning. Okay, so have you seen the lectures recording? Please be honest. If you haven't not seen, that's fine, like we can give overview of that. But yeah, if you have seen it, then you might ask me questions if you have any doubts from the lectures. I guess almost half of the people have watched and remaining half have went through the lectures. That's fine. Okay, so as I told, there are three paradigms. Majorly, there are three paradigms of learning. One is supervised, one is unsupervised, and another is sequential learning. Okay, so we'll dive into each of the dive deeper into each of the paradigms or each of the types of learning. Okay, so first is that supervised learning. So we know we have data. Okay, so data means like an image can be data, a text can be data, a music can be data, right? So all of them are data. Anything is data to us. For example, in your day-to-day life, for example, you are asking 10 questions to your friend, or maybe one question to 10 of your friend. So that question is your the question that you are asking is also data, and the response they are giving is also data. Maybe you are clicking a picture, or maybe you are clicking tens of pictures in a day. So this is also a data. Maybe you are singing a song and you are recording it. So that recording is also a data. So everything in and around us that can be documented as per say, like documented in the sense can be written, can be captured, can be recorded in the form of voice, is a data. And such data, like some data have corresponding labels. What do I mean by labels? Labels means you are clicking a picture of a dog. So your data is the image, okay? And the label is the dog, okay? So you have an image, and then in the image there is a dog. So that image is a data, and the dog is the label of that image. Is this clear to all of you? Now, if you click a picture of a cat, so can anyone tell me what is data here and what is label here?
The label is the cat and data is that image of that cat.
Yeah, correct. So using this kind of
Explain
things,
one thing, sir.
yeah, using this kind of data, we actually do predictions. Okay, so in unsupervised learning, what we have is we only have like what I can say, we only have the data, but we don't have any labels. Okay, maybe you have hundreds of pictures, you have 100 pictures of some cat or dog maybe, but you are not able to like those pictures are not at all that clear, but right, but still they are data. So we cannot label them whether it is a cat or whether it is a dog. Fine. Like in the previous case, what's the difference? We have a clear pictures. Those pictures are our data, and we can clearly label them. Yeah, this is a picture of a cat. This is a picture of a dog. But let's say again, we have 100 pictures, but now the data are not that clear. We, as a human eye, naked eye, we cannot say that it is a image of a cat or it is a image of a dog. So that's why we only have features here, but not the corresponding, like nobody have labeled it as this is the image of a cat or this is the image of a dog. Nobody had explicitly labeled it. So we have just the features. Now our task is to find the pattern. Okay, now our task is to find pattern in the data. Like it might be the case that there is some underlying pattern in the series of the data set, and it might be possible that there is no pattern followed in the data set. Okay, so that's what our learning algorithm will do. Its purpose is to find whether some patterns are there in the data set or it is not. And then I guess sequential learning will okay, see later, because that is not that important as a part of this. But to give you some basic understanding, sequential learning is like you can say it is semi-supervised. Like it is completely not out of the level, but not explicitly labeled as well. Like example, training a robot. Okay, during training a robot, if some robot is bound to, let's say it is bound to wash a dish, the objective of the building that robot is wash dishes. Okay, now we are giving instruction to the robot that wash dish. If the robot is able to wash it, we are giving that robot a what I can say reward. Okay, we are giving that robot a reward. But if it is not able to do it, we are punishing that robot. So this reward and punishment is nothing but these are just mathematical what I can say, these are just mathematics. As of now, you can think like these are mathematics, because what we can say by reward, like we cannot gift a chocolate to a robot. It doesn't make sense to a robot, right? Or we cannot beat a robot. It doesn't make punishment to a robot, or we cannot scold the robot, right? It is not it is punishment in human sense, but not for the robot. It doesn't make sense. So it is some kind of mathematics. Let's say if it is doing its task well, we are rewarding it. That means we are, let's say, adding some, we have some counters, let's say reward and punishment. So if it is doing some task well, we are adding some points to its reward counter. If it is doing the task not so well, we are punishing it by removing some rewards from its counter. Correct? So that's what supervised learning is. So that's not sorry, that's what reinforcement learning is. So that's
Sir,
yeah.
so it basically works on trial and error method, right?
Yeah, completely. This reinforcement learning is complete trial and error. Okay, it uses exhaustive search, like all the possible scenarios that is present in the environment. It tries everything and then it try to maximize reward. Okay, its main aim is to maximize reward. Like if you are fulfilling your objective, automatically you will get higher reward, right? So its main objective is maximizing rewards. So now supervised learning and unsupervised learning. On this image, you can see you want to learn a topic. Let's say this, let's say machine learning. Okay. So if some teacher is teaching you what machine learning is, that means he is giving you the data or the knowledge. In that case, he is giving you the instruction or the data to understand what supervised learning is, and he is labeling everything, right? But now you want to learn supervised learning, you want to learn machine learning, and nobody is there to supervise you or give you supervision, right? To show you the path. You just open some random books and you try to learn it yourself. That means you are trying to find some pattern or you are trying to learn something new without any supervision. So that's the difference between supervised learning and unsupervised learning. Is whenever some supervision is involved, someone is telling you like, I have this and I am labeling this data as this thing. So this is called supervised learning. But whenever I have the data, but no one is explicitly labeling it, that whether it is some form of data or some form of cat or dog in that data, it is unsupervised learning, right? So in this, from this image also, I think it is clear, like teacher is trying to teach you something. That person is supervising, right? That means someone is there to show you direction. But in unsupervised case, you just have books. You have to yourself find out the directions or yourself find out the pattern. You don't have supervision provided to you. Is this fine? The difference between supervised and unsupervised learning?
So I have a doubt in ordinal classification and multi-class classification. I just couldn't get the difference between them.
Okay, so in the next section, we will encounter these topics, then we will discuss that, okay?
Okay.
Yeah, so is the difference between supervised and unsupervised clear? Okay, so the main thing you should remember, like if I can try to conclude, in supervised learning, we have a data and label. So someone is explicitly labeling the data set. Okay, that means someone is giving us supervision. That is supervised learning. And in unsupervised learning, we are just hand down with the data. Someone have passed us data and no supervision is given what to do with the data. It is our purpose to explore the data set and find some patterns. Fine. Okay.
Yes, sir.
Moving forward, what are different types of supervised learning? So think as a tree, like on the top it is machine learning. Inside machine learning, we have three kinds of learning: supervised, unsupervised, and reinforcement. And then again, inside supervised learning, we have two kinds of learning. One is classification, another is regression. Okay, so if I create a doc. Okay, so just machine learning, and then there is supervised learning, unsupervised learning, and sequential learning will be the proper term. But okay, now think as a reinforcement learning. I will not say sequential learning now. Reinforcement learning. Okay, so inside this supervised learning, we have regression and classification. So are you able to explain, like, are you able to get the structure, how things are working? So supervised learning is the, machine learning is the main thing. Inside that, we have three kinds of learning: supervised, unsupervised, and reinforcement learning. So in supervised learning, we have data and labels. In unsupervised learning, we have only data, find pattern ourselves. And to keep it simple, trial and error. Okay, so trial and error. So in regression,
What
what
is
is
needed trial and error, sir?
trial and error means you will try. If it is giving us a good result, we'll reward the agent or the robot. In our case, that robot is our agent. If it is not giving good result, we'll try to prompt it differently, and then we'll see. And if it is again doing well, we'll reward that. If it is not doing well, we'll punish that. Okay, so we'll try an error. We'll try to exhaust entire search space. We'll try everything possible to train it well, and our main objective is to maximize reward. Fine.
Yes, sir.
So now the main thing is regression and classification. So these are very important things. These are this will be helpful throughout your life. So what is regression? So regression is always the output will be continuous value. Okay, and in classification, discrete value. So what I mean by this? All of you aware about a real number?
Yes, sir.
Yes, sir.
Yes, sir.
So it
Yes,
is
sir.
combination of your
Yes, sir.
rational and irrational number, right?
Yes, sir.
So whenever the output of our model or our learning, as of now we should say learning, whenever the output of our learning is something continuous value, that is regression. It can be anything. Maybe, for example, let's take an example. You have 50 friends, okay, and you collect their height and weight. Now you want to make 51st friend. Okay, you already have 50 friends and you have collected their height and weight. So these are my features. Okay, these are known as my features. Okay, my data. And then based on that their BMI, maybe you are labeling them, right? You are labeling them as healthy,
I mean, once again, sir.
maybe fit or obese or skinny, anything like this is not body shaming, but you just labeling them based on their BMI. Okay, so here what you have data, right? Height and weight is your data, and level is your, like, he is healthy, healthier, like let's say divided into 3 classes, whether he is fit, obese or skinny. Okay, so now what I will do, if I try to predict what will be the height of my 51st friend. Okay, so okay, instead of friend, it will be much better if I change it a bit, like 50 days sales of an ice cream store. So it will be a good example. 50 days sale of ice cream store. Yeah, 50 days sale of ice cream store. Okay, and collecting information such as collecting info such as number of units sold, that is number of ice cream sold, and amount received. Let's say these are the data I am collecting, and I am labeling each day as what I can label them as, maybe high sale day, low sale day, and average sale day. Okay, so this is completely subjective, right? Like let's say if high sale day, maybe if he have sold 100 ice cream in a day, that is considered something above 100 ice cream in a day is considered as high sale day, right? Greater than 100. And low sale day is something like where he have sold ice cream less than 50 in a day. And average sale day is anywhere between, if you have sold between 50 to 100 in a day, so that is considered as average sale day. Now what we will do, predict. We can predict 2 things here. So if I am considering number of ice creams, so predict number of ice creams to be sold on 51st day. Okay, so tell me one thing. In this case also, okay, tell me one thing. Number of ice creams to be sold in 51st day. will it be a real number? Like it can take any values, right? Any values. For example, it can be 1, it can be 2, 3, it can be 500 also, it can be 50 also, right? No fixed value is there, correct? But based on the previous sales, right? Based on the previous 50 days of sale in an ice cream store, I am trying to predict how many ice creams can be sold in that 51st day, correct? Are you able to understand, or is it getting difficult?
Yes, sir.
So it's okay.
So it will be discrete value, right? Anything between 0 to infinity, right? Any value between 0 to infinity, correct? It can be 0, 1, 2, 3, 4, 5, 6, all the way up to 99, 98, 100, 150, 200, anything can be possible. But based on this data, we will try to get some estimate that, yeah, maybe 121 ice cream, maybe 121 ice cream will be sold tomorrow. Okay. So these things are actually called regression. Okay. So the much better example will be like prediction of rainfall. So in this example, the output is always in discrete, right? Discrete in the sense discrete number, not the discrete that I have discussed here, discrete value. Okay, discrete number, because it can be either 1, 2. You cannot say that tomorrow 13.5 ice cream will be sold. It can either be 13 or 14, correct? Still, it is a regression because we are trying to predict some value, right? Some numerical or some real value, because 51 is also because 121 is also a, although it is a discrete value, like exact, not a continuous value, that is 121, some defined number, not in point precision, but still it is a real number, right?
Yes, sir.
Okay.
Sir, what does it mean by discrete?
Discrete means something like 1, 2, 3, 4, but continuous is something like 1.2, 1. Like any number that is taken in fraction is continuous. Okay, so in discrete also it comes, for example, you are building an classifier. It will be provided data and it have to decide whether it is a cat or dog. So the output is always discrete. The output can either be cat or dog. It cannot be anything else, right? But in continuous case, if I am trying to predict something, it can be possible that it is in point. For example, prediction of tomorrow's rainfall in millimeter. Those of who are in Chennai, they might know that since yesterday it is raining here, and yesterday it was raining and today it was raining. So let's say yesterday it have rained 150 millimeter. Let's say, just an example, and today it is raining 123.56 millimeter. Now, based on that, you want to predict how much it will rain tomorrow. So now these things are my data. Okay, these things are my data, and I have to predict how much it will rain tomorrow. So maybe some, after training it on these 2 days of data, the output can be like something like 134.56 millimeter. We are predicting that tomorrow 134.56 millimeter rainfall will happen. Okay, so you see my output here is continuous, 134.56. It can be anything. It can be even 184, right? It can be 150, 173.56. It can be anything, right? And it is not taking any discrete value, right? For example, in this case, cat dog classifier, it is discrete value, like only out of these two, either cat or dog. But here it is like continuous value, correct? Now, how can I think this problem in the form of classification? Okay, same problem in the form of classification. So this labeling I have done: high sale day, low sale day, average sale day. So now if I think this problem, if I want to think this problem in the form of classification based on the number of ice cream sold. So if I am deciding that 121 ice cream is sold, okay, now I want to classify it, whether it is a high sale day, low sale day, or average sale day. So what do you think it will be the output?
High sale day.
Yeah, so
It will
that's
be
a
a high sale day.
high sale day, right? So here you see the problem is same, but the formulation is different. Here in this regression case, we are finding the number of ice cream sold to be sold in the 51st day. So what we are finding? We are finding something continuous value, right? Number of ice cream, some real value we are trying to find. So it is regression problem. But here we are not trying to find any real value. We are trying to classify the 51st day, whether my 51st day would be high sale day or a low sale day on an average sale day. Okay, here we are trying to classify the type of the day, and here we are trying to classify how many ice cream would be sold in that day. So is this setting clear to all of you? Based on the output that I want, that is what my machine learning algorithm I should be training. So if I want my output in real value, my kind of algorithm that I should be training is regression, and the kind of problem that is called is regression problem. If I want something to categorize or classify, that comes under classification problem. Is this fine?
Once again,
Yes.
Okay, so if we go back and solve some example, it will be more clear. So you see, types of supervised learning is classification, where our target is a categorical value. Okay, and regression is a regression where target is our continuous value. For example, rain, amount of rain. So in rain, we are classifying whether tomorrow it will rain or not rain. So if we are classifying, right, like output can be either yes, it will rain, or no, it will not rain. Correct. So this is the classification. But now I want to like predict how much it will rain. So it is a continuous value, right? Maybe 137.22 millimeter it will rain. So it is a regression problem. Okay. Now moving forward, just think carefully before answering this. If you have to predict whether loan should be given to a customer, what type of task is it? We have to predict whether loan should be given. Like, what's the possible output? It can be given, it cannot be given. Right? So is it a regression problem or classification problem? Just think before answering. What is the possible output of this question? Ask yourself whether it is the output of this question will be continuous value or something I am classifying that, yeah, I can give a loan to that person or I cannot give loan to that person.
Sir, regression.
So why regression, do you think?
Because it is a continuous term.
Because it is a prediction.
Prediction of what? Read the question again. If you have to predict
Sir,
whether loan
classification.
should be given to a customer, what type of task is it?
Classification.
What will be the answer of this question? Whether loan should be given to a customer or not, what would be the answer of this question? It will be
Yes or no?
Yeah.
Classification.
So if it is yes or no, then how come it become regression? Because in regression, as we have seen, right? In regression, we have already seen it is continuous, right? But in classification, the output is categorical. That is, what are the two possible categories? Yes or no? These are the two possible categories, right? So what would be the answer?
Classification.
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 Yeah, correct. It should be classification. Okay, I think most of you guys haven't like given this as wrong answer. Okay, anyway, the next question, if I just think before answering, just don't rush to answer this. Just think about the question, what it is asking. What will be the possible output of that question, or what will be the possible answer? Whether it is some number or will it be some classification thing like yes, no, cat, dog, something like that. If it is that kind of thing, then it's classification. If it is something real value, then it's regression. Okay, if you have to predict how much loan, think how much. Now it is asking how much loan should be given to a customer. What will be its output? How much?
regression.
It will be number like 1,000 rupees, 2,000 rupees, 3,000 rupees, anything. 0 to infinity. Right? As I told, same question, right? The question is of loan. Now the question is framed differently. In the earlier question, it was whether it should be given or not. So classification. Now how much loan should be given? So some amount, the output would be some continuous value, right? So regression. I hope this is clear to all of you now.
Yes, sir.
Sir.
Okay. So moving forward. Now someone asked what is ordinal classification and what is multi-class classification in the beginning of the session, right? So now we are going into the classification phase. So in classification, if let me go back to my, yeah. So in classification, there are again two types. One is ordinal, before that maybe binary and multi-class. And then maybe I'll say ordinal. Ordinal. Okay, so binary means what? Only two possible output. Binary means two. Okay, bi means two. Okay, and only two possible. Only two possible output. For example, yes or no. Then cat or dog, and spam or not spam, right? We receive mail, right? So Google decide based on the context that it has on the mail, that whether it is a spam mail or not spam mail. So if it is a spam mail, it puts into spam folder, correct? I hope all of you have experienced this once in a lifetime. If it is a spam mail, puts in the spam filter, and if it is a non-spam mail, it is just put in the regular mail space, right? So this is a binary classification. Actually, Google is using this classification thing, okay, to decide whether our mail that we are receiving is a spam or not spam. Okay, but in multi-class, it is more than two class. Okay, more than two class means it is 3, 2 countably infinite. Countably infinite means, what do you mean by countably infinite? Countably infinite. Okay, so countably infinite means it is a large number, but something that we can count. Okay, so usually we will not see even in real world examples also, in multi-class also we'll see maybe 3 to 10 possible classes at max. Like if it is less than 3, then it's binary. Less than 3 as in only 2. In binary we can have only two, no other cases. Like we cannot have only one possible case, so that's not a classification problem. If we have two possible scenarios, that's binary. If we have more than two, and it can be anything, that's why I have written countably infinite. But you should know what this number is. That's why countably is as the adverb is added here. Okay, so that countably infinite can be 1000, 2000, 3000, but in real world cases it's not like that. Usually 3 to 10 or 12, maybe that many classes are sufficient. Example is that, for example, if we want to build a classifier that classifies, so your data is, you are putting an image and it classifies
What
which
is make classifies?
number is it. Classifies means out of all the possible levels that you have, it will have only those possible answers. For example, 100 images are there and its level can be cat or dog. So all the images that belongs to this data set can only be in the cat class or can only be in the dog class. It have to be either of the two. So that's what we mean by classification. Okay, there is no third scenario possible. So best case scenario is that 50% images, like 50 images are of cat, 50 images are of dog. Clear?
Yes, sir.
Okay, so what I was telling, okay, so you are building a classifier. So classifier means some model you are building where the input will be your image, and it is classified which number is it, whether is it a 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. Okay, so how many classes are there for this problem? How many classes are there?
10.
Correct, because let's say I am providing 1,000 images. Okay, I'm providing 1,000 images into the classifier, and it can predict which number is it. Okay, and it will be out of only this many possibilities. This is all these 10 possibilities. So we know that in this 1,000 images, only images with label this are present. Okay, let's say first image is of 0. Okay, so if I show you in real world MNIST data set, so this is what I am talking about. Okay, I hope it is clear to all, like visible to all. Okay, this is what I am actually talking about. So this is a data set, right? So this is an image of a 5 and its corresponding label is 5. It is an image of a 0, its corresponding label is 0. It is an image of a 4, its corresponding label is 4. Similarly, like this kind of images are, these are my images and these are my corresponding label. So as I told, I have 1,000 of the images, but my output can only be between 0 to 9, right? That is, it can either be 0 or 1 or 2 or 3 or 5 or 6 or 7 or 8 or 9. Either of the one out of the all the 10 possible cases. Is this clear?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So that is called multi-class. But let's say my classifier, I have same thing again, 1,000 images.
Sir,
Yeah.
sir, in the multi-class classification, can it really infinite outcomes like as we saw in the regression that there are infinite outcomes?
That's why I have mentioned, right? Countably infinite. That means from the before the hand, you should be knowing how many possible cases are there. Like it can be possible that 1,000 classes are there, 2,000 classes are there, but you should be knowing that number, right? That number can be very huge. That's why infinite. But again, that infinite means that you should be able to count that. Okay.
Okay, sir, that means there can't be infinite outcomes.
Yeah, there can't be any infinite outcomes. It can be very huge number standing, maybe 10,000 classes, right? It is like tending towards infinity, 10,000, maybe 1,000 classes, maybe 1 lakh classes. But that number is countable, right? I can count that 1 lakh class, correct?
Thank you, sir.
Okay. Okay, so in binary case, let's say again we have 1,000 images, and now my images are of cat and dog, and it is classifying which animal is it, and only possible output are my cat, comma, dog. That's it. Only 2 cases, right? Only 2 cases, cat or dog. Okay, so it is a binary classifier. This is a multi-class classifier. Now, what is ordinal classifier? So ordinal classifier is not something different. It is like just our order of the label method. Order of the label matters. And that's it. It can be binary. It can be ordinal. It can be multi-class, right? But the order that we have of the level is matter. For example, can we say that here cat is of higher importance than dog, or dog is of higher importance than cat? Can we say something like that? Anyone?
No, sir.
No, that doesn't
No,
make
sir.
sense at all, right? That doesn't make sense at all.
No.
Even here, can we say that 9 is greater than 0? Like greater in the sense, like 9 is of more importance than 0, or 5 is of less importance than 8. We cannot say something like that, right? Because our order here doesn't matter. Correct? So
Yes, sir.
in ordinal classifier,
Sir.
our orders matter. So what an example could be like? Wait a second, just give me a moment. Yeah. So one example could be like, you are going to a maybe you want to go to a restaurant, okay, and you are asking your friend in your locality, maybe 3 kind of restaurants are there, okay. Best, average, worst. So can we say that here our orders matter? Best is better than average, average is better than worst, but average is lesser than best, and worst is lesser than average. Correct? Order matters here, right?
Yes,
But
sir.
still we are classifying it as into only 3 possible cases. Like the restaurants can either be best or average or worst, but in this case our order matters. Best is better than average and worst. Average is better than worst but less than best. Correct?
Yes, sir.
Yes, sir. Yes, sir.
So main
Yes,
thing is
sir.
binary and multiclass, and when if our order matters, then that's called
Yes,
ordinal.
sir.
Okay, so yeah, let's go back to here. So as I was telling, target has some order. That's it. Now, just don't answer quickly. Just read the question carefully. Predicting spam versus non-spam. So does my spam is greater than non-spam or my non-spam is greater than spam? Does the order matters here actually?
No,
Anyone?
sir, maybe the order doesn't matter.
Yeah, order doesn't matter. It is just classifying, right?
It is just
Whether-
classifying
Yeah.
into two groups.
Yeah, classifying into two groups, whether it is a spam mail or non-spam
Or
mail. So that's the
illness.
classification. Okay, so yeah. Can you move to the next one?
Sir.
Just wait. Predicting grades of a student. Listen. Grades. We know that A is greater than B, B is greater than C, C is greater than D. So order
Sir.
matters.
Sir, here grades does mean by AB or the like numerical data 80 out of 80, 70 out of
No.
75.
Grades always A, B, C, D. Okay. So here we know order matters because A grade is greater than B, C, D, E. Correct? Then B grade is greater than C, D, E, but less than A. Right? In grade, our order actually matters. Okay.
Okay, sir.
I hope by the like result of the poll, all of you are getting what is what I want to convey in the session, like the supervised, unsupervised, ordinal, classification, regression thing, right?
Yes,
Okay.
sir.
Yes, sir.
Yeah. So next thing is clustering. So before going to clustering, let's go back. Okay. So clustering. Here we don't have any label. We just have the data, and it comes under unsupervised part. Okay. It comes under unsupervised part. Clustering. Okay. So some data points are there. We have to cluster them. Cluster means we have to form some foundation between them. Like let me first complete it and then I will explain for some data points are there. We have to cluster them based on some matrix. What is this matrix? Similarity. Okay, based on similarity, we have to cluster them.
Sir, are we not going to study the types of unsupervised learning?
This is unsupervised learning, right? Clustering. We have seen supervised learning, we have regression, classification. Inside classification, we have binary and multi-class and ordinal, right? Now we are moving to unsupervised learning. So in unsupervised learning, only data is there. We have to find pattern. We don't have any supervision. So clustering is one kind of unsupervised learning. Okay. So in clustering, it is a type of unsupervised learning. What we do? You see, this is my this is my data. Okay. So focus on this part. This part of it. This is my data. Okay. And no supervision is given to me. Nothing. No supervision at all. Now it is my duty to cluster the things that I am seeing on that image. Okay, so one possible cluster is that I am clustering them. Both of them are banana, right? Visually, you can see both of them are banana. One is green, one is yellow. Now I am clustering. This is another cluster, right? Cluster 2. Both of them are grapes. One is violet and another is green. And let's say both of them, like all the three of them are triplet is the apple. One is yellow apple, one is green apple, one is red apple. Fine. So we are clustering based on the type of fruit. This is a one cluster. This is a second cluster. This is a third cluster. All right. Another possible way of clustering is that clustering based on the color. So yellow fruits are clustered at one cluster, green fruits are clustered at one cluster, and red fruits are clustered as another cluster. So both of them are correct. Why both of them are correct? Because someone have provided us image and haven't told us what to do with the image. This is our own consciousness that we have come up with the two different type of clustering. One based on the kind of the fruit we have, and another based upon the colors of the fruit we have. So both of them are correct. Fine.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So I hope the intuition behind clustering, what actually clustering means, is clear. So anything, think about some physical foundation. Anything inside this ring is like, this is one cluster where all the bananas, maybe let's say purple banana is there. For example, hypothetical scenario. If some purple banana is there, so it will come into this cluster, correct? Because this is a cluster of banana. If some violet grapes are there, it will come into this cluster because this is a cluster of grapes. And if some pink apple is there, apple will come into this cluster because this is a cluster of apple. Now let's say some yellow fruit. Okay, yellow fruit is coming, so it will be in this cluster. Some red fruit is coming, it will be in this cluster. Some green fruit is coming, it will be in this cluster. Okay. So these are two different type of clustering. One based upon the type of the fruit or the kind of the fruit, another based upon the color of the fruit. Okay. So just think carefully before answering. Your Google Photos app automatically group picture. What is happening? Whether it is a regression, it is a classification, it is a clustering, or it is an ordinal classification. And I hope all of you will be able to answer it correctly because this is a real life scenario. We capture thousands of pictures, and whenever we go to Google Photos, we can see that some of them are like, maybe our Google Photos is classifying some of them as a picture of a dog, some of them as picture of a flower, some of them a picture of your friends. Inside also friends, let's say you have 3 different friends and you have 30 pictures with each one of them. So all of them will be clustered separately, right? Correct. So this is a clustering problem. Yeah. Now going forward, the algorithm used for clustering is called k-means clustering. So in k-means clustering, what happens is that k-means clustering use some methods of calculating Euclidean distance. So what is Euclidean distance? So I have 2 points, and these are very important because questions on assignment are asked from these topics. So let's say I have 2 points. Okay, on a Cartesian plane. So what is a Cartesian plane? Before that, let's discuss Cartesian plane. So let's say I have a real line, right? This is a real number line, right? It can be 0, 1.
I am having a problem in differentiating in between the clustering and classification. Can you clear it, please?
Yeah. So classification is like, as I told, I have given you 1,000 images. I'll explain the example, 1,000 images. And now I am telling you, classify these images either into dog or cat. Okay. So only 2 possible output is there. And I am telling you, after giving you the 1,000 images, I am telling you that you have to do that. So supervision is provided to you, right? So this is called classification. Now again, I am giving 1,000 images to your friend. Okay. So this 1,000 images I have given to you, and I am telling you, classify them into cat or dog. Okay. So you have 2 buckets and 1,000 images. So the images of the dog you will put in this bucket, and images of cat you will put in this bucket. Now what I will do, I will give same 1000 images to your friend, and I will not ask him anything. I will not tell him anything. So now it's his duties. Now he will look into the images. So what one possible cluster thing he can come up with this, like he can cluster them into cat images, dog images. So one possible thing. Another possible thing that he can come up into is like images of all the black animals present there, all the white animals present there, all the brown animals present there. Okay, so two possible scenarios are there, right? And both of them are correct because I haven't given him any supervision. I haven't told him that, yeah, you should segregate the animals based on the colors, or you should segregate the animal based on their type. If it is a cat, put it into cat type. If it is a dog, label it into dog. Okay, so no supervision is provided, just features are provided to him, and he have find the pattern himself from the data. But here I have provided him the images and the labels. His task is just to put it into the correct bracket, right? Like I have provided you the image and the labels of each of the image. Your task was to put it into the correct bracket. So this is a classification where my output was predefined that it can either be cat or it can either be dog. That's it. But in classification, there was no predefined output. It can be anything. The first case can be, it can be cat or dog, or the second scenario can be, it can be clustered based on the image, based on the color of the fur of that animal. Clear?
So, okay. So you mean in the k-means clustering, we can just classify, I mean, just classify, cluster the objects in another kind of, groups, whatever
Yeah,
it
we
is.
just find groups ourselves and no supervision is there. Okay.
Okay, it's kind of something, self-analysis or understanding the patterns,
Yeah, it's
maybe.
self-learning, correct. Okay, it's self-learning. But in unsupervised, in supervised type, it's like supervised learning, right? Supervision is there. So the thing I was there, like this is a real number, right? We can have a real line, right? 0, 1, -2, correct? Oh, I hope all of you are aware about this, right? This is a real line.
Yes,
Correct?
so
So first we have point, and then collection of point is a real line. And then if we have two real line intersecting like this is called our Cartesian plane, right? X-axis and Y-axis. Is this clear to all of you?
yes,
Yes,
sir.
sir.
Now let's say I have 2 points. This is 1 point. This is another point. Okay. And I want to find the distance between these 2 points. Okay. Yeah. And I want to find distance between this point to this point. So this distance is called actually my Euclidean distance. Okay. Euclidean distance. And actually K-means algorithm uses this distance metric to find similarities. Okay. Clear? The intuition part, is it clear? What this K-means algorithm uses? It uses this Euclidean distance metric to find similarities. Now, if I go to next slide, let's see what we have. Yeah. So steps in the algorithm of the K-means. So K-means itself is an algorithm. Okay. It is an unsupervised algorithm. And its step is pivot step and cluster step. Pivot step and cluster step. So first of all, I have this many, don't think them of cluster as of now. I have all these data points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I guess 13 data points are there, right? So 13 data points are there. 13 data points are there. Okay. And I am taking 3 pivot elements. One is this yellow data point, another is this green data point, and another is this brown data point. Okay. Now what I'll do, I'll calculate distance from each of the pivot to each of the elements. So first I'll calculate distance from this to this, then this to this data point, then this to this data point, then this to this data point, this to this data point. What distance I am talking about? Can anyone tell me?
Euclidean distance.
Yeah, correct. Euclidean distance. This to this to this, and this to this to this to this. Okay, we can observe that now it is not up to scale, but there will be some numbers given, right? This is again on Cartesian plane, correct? We can see that, right? So I'll calculate the distance. Then similarly, I'll do for all the other colors. Like for now for brown, I'll calculate distance from here to here, here to here, here to here, this one to this one, this one to this one, and then this one to this one, this one to this one. Like, are you getting the intuition that from each of the pivot element, I will find Euclidean distance, right? And then remaining for green one. So from green to this one, green to this one, green to this one, all the elements. Okay, all the elements here, all the means except the pivot elements, all the elements. Okay, so is it clear? I'll calculate all these distances. Now, based on the similarity. So what is the similarity? Similarity means whichever is in lowest distance, whichever is residing in the lowest distance from the data point, will assign the color of that into the data point. So what I mean by this? Okay, so what I mean is basically I have calculated distance of this data point, right? I have calculated distance of this data point with this yellow one, brown one, and green one, correct? I have done that, correct?
Yes.
Okay.
Sir.
Now what I have to do is I have to see which is in the least distance from this data point. So from this data point, I have calculated this three distance, right? This one, yellow, and this one. And visually also, we can see from this data point, yellow is the nearest one, right? So I'll assign it as yellow color.
Excuse me, sir.
Yeah.
Sir, if there are two colors and they have one data point, but they have equal distance, like both, then which color would it choose?
So basically, usually in practical scenario or real life scenario, these things can happen. At that point, you can choose either of the color. It is not that necessary. But in terms of mathematics or theory, whenever you will be asked to solve question, you will not be given this kind of scenario. Okay.
Okay, sir.
So this data point will be given yellow color. Now, similarly for this data point. Okay. So for this data point. So for this data point, again, I'll calculate this from here to here, here to here, and here to here. So which color is the nearest?
Red.
Brown.
Red.
Yeah, red or brown, whatever you say, that one, right? So now we'll assign it a brown color. Okay. Likewise for all the other data points. For this data point also same thing will happen. You can visually see it is nearest to brown, right? Again for same data point, it will happen. So it is nearest to brown. This is nearest to brown. So at the end of that step, this is the image that we will obtain. Clear? Okay.
Yes, sir.
Now what I have to do?
Sir.
Yeah. Now what I have to do? I again have to like select another pivot element. So first I have selected these three as my pivot element. And after selecting these three as my pivot element, this is the clusters I am getting. Okay, this is one cluster. This is another cluster. This is another cluster. But can we see that in the cluster, all of the elements are of same color or some of them are of different color?
Yes,
Some
sir.
are, some are different.
Some are
right?
different.
So that means our algorithm haven't converged. Okay, so focus on the term convergence. If all the elements are of same color, at that point we can say that our algorithm has converged. Since all the elements are not of the same color, that means our algorithm haven't converged. So now I have selected this element as my pivot step. Like from this cluster, I have selected this element as my pivot step. Then here also this is my pivot, and here this is my pivot. So again, I am doing the same process. from this point to this point calculation, this point to this point calculation, this point to this point calculation, this point calculation, this point to this point calculation. Okay, same thing, whatever we have done, right? Exhaust the entire search space present here. So this is my entire space, and I am calculating all the corresponding data points it have, right? All the Euclidean distance from the corresponding data point. Okay, for all
So,
the
sir, it makes decision on the basis of the Euclidean distance.
yeah, Euclidean distance. So the metric I was talking about, see, based on some metric, we have to cluster based on some metrics, and that matrix is similarity, and similarity is just a fancy name from Euclidean distance. Okay, so going forward, so it will try on doing these steps. So 2 steps of this algorithm is, one is pivot step, another is cluster step, pivot step, cluster step, pivot step, cluster step. So it will keep on doing this step until it see that, let's say 10 times it is doing, right? So this is first time, then this is second time, third time. So this is the result of the, in the first iteration, this is called iteration. So how many times we run the algorithm is called iteration. So in first iteration, I have selected this as my pivot, and then I have got this cluster. So iteration 1 is complete. Now iteration 2, again I have selected this as my pivot, and I have got some clusters. Maybe here it is showing converged, but let's think it hasn't converged, right? So some cluster I have got. Again, some third iteration, I have selected my pivot and got some cluster. And fourth iteration, selected some pivot, got some cluster. So let's say in fifth iteration and sixth iteration, my pivot haven't changed. My cluster haven't changed. Okay, at that point, we can say that our algorithm has converged at fifth iteration. So in this case, let's say in fifth iteration, this is the result of my fifth iteration. This is the cluster I have got. And as a result of the sixth iteration, also same cluster I have got. Now, if I do 7th, 8th, 9th, 10th, 100th, 1000 iteration, cluster will not change because it has already converged. Does that make sense to everyone?
So,
Yes.
Yeah, ask. Any doubt?
no, sir, nothing, sir. Got it.
Yeah. So
No, sir. Yes, sir.
important things is that the intuition, the maths is not very important. As a part of math, you should be knowing like what is Euclidean distance calculation. That's it. Okay. And then algorithm is important. You have to select pivot element at every step and then find its corresponding cluster. In the second iteration, you have to find pivot element. Sorry, you have to select pivot element and then find the cluster. And in the third step, again, third, fourth, fifth step. So let's say in some 2 iteration, the cluster haven't changed. So we can say that in the previous iteration, it have converged. So for example, in our case, we have seen that in 5th iteration and 6th iteration, our cluster output haven't changed. So we are concluding that in the 5th iteration, our algorithm has converged. Clear? Okay. So moving to the next question. So what is the limitation of k-means? So here, the first point is requires value of k, and here spherical clusters. So requires value of k. So from these data points, it can be possible that 3 clusters can be there, 2 clusters can also be there, 4 clusters can also be there. So we have to beforehand specify how many clusters we want. That is, this k is a variable. This k is not fixed. Okay. So if I want 3 cluster, this is known as 3 means clustering. If I want 5 cluster, this is known as 5 means clustering. In general, this algorithm is called k-means clustering. So k means the number of clusters. So can anyone tell me what will be the name of this clustering? Yeah, because 3 cluster output we have got as a result of the algorithm, right? So this is called 3 means clustering. Now going forward, we have seen that clusters are usually Euclidean distance actually calculate our Euclidean distance usually calculate our distance, similarity distance, and the clusters produced as a part of the Euclidean distance are spherical in nature. Okay, spherical in nature means circular. Okay. So these are the limitation of my k-means. Now this one you see. this data point. This data point is in both the clusters, correct? It is in purple cluster as well as in yellow cluster, correct? So these are some of the limitations of K-means algorithm. Clear? Why the limitation? Because it is a spherical in nature. Let's say my shape of my cluster was something like this. This cluster was something like this, right? Something like this maybe. And shape of this cluster was something like this. So then it is not an issue because all the data points are lying exactly in one cluster, correct? But since our data points are, our clusters are spherical in nature, so as a result, this data point is lying in two clusters. This data point is lying in both yellow cluster and purple cluster. Clear? Okay. So here you see my data point is in this way. So can I find some cluster? Let's say if I find using Euclidean distance, let's say this one. So this is one of my cluster will be like this, and another cluster will be like this, correct? So it is, sorry, it is actually circle. Okay, this will be a circle. Okay, this is a circle. One cluster is like this, another is like this. So can you observe that in this red cluster also some purple points are there, and in this purple cluster also some red points are there. Okay. So to deal with that, we this is the decision boundary, you can say. This is the decision boundary. So any data points lying on the left side of that cluster will be red. Any data point lying on the right side of the cluster will be purple. Okay. So the problem is that, or how to deal with that, is called K-means clustering. So that K-means cluster, not K-means clustering, it was kernelized clustering. Okay. So kernelized clustering is not a part of your syllabus, so we can ignore that. Okay. So I hope these things are clear. These basics are clear.
Yes,
Okay.
sir. So,
Yes, sir.
can we do this clustering thing in the orange data mining?
Yeah, that's 100% possible.
Okay.
Yeah.
So we can just like we used to make the graphs of the data points there. We can do the clustering there, right?
Yeah, we can do that. So you see, there are maybe some data points, right? Something like that. Okay. Some data point, something like that, and then some data point again, something like that. Both of them are of different color, but circular in shape. So if I run K-means algorithm, right, on these data points, where maybe like input data point is of orange color, but outside data points are of purple or blue color. And now if I run K-means algorithm on this, so it will produce me cluster something like this, right? So this is the output of my K-means output. But in reality, my cluster should be something like that, because first this one is one cluster, inner circle, right? And this one is another cluster, outer circle. So this is where K-means algorithm fail. It will try to give me clusters like this, but in reality it should be clustered like this. Okay.
So my doubt is the real cluster, like when you're creating the outer circle, the inner circle automatically becomes the part of that circle.
Yeah, it becomes a part of that circle, but
But it
that's
is
how our,
different.
that's how, like, I can say that our that original data points are like the underlying
So
patterns in
original
the
data
original data point.
points means original data points get manipulated.
Original data points get manipulated means I'm not clear about the question. Can you elaborate more?
I mean, like when in the true output, like there are the inner circle is part of the outer circle. Like
Yeah,
it is what it should be, but in the K-means clustering, it is dividing and like, making the boundary out there.
yeah,
But original data points are not there, right? So it is the manipulation of the data points at some point, some
yeah,
places.
correct. So that can be possible. So that's the thing I was telling. Let's say we have some data points and I want to find two clusters. So we as a human know, maybe we know, I don't know how, but we know that output should be like this, right? One should be orange small circle and another should be purple bigger blue circle, right? And for finding the cluster, we usually use K-means algorithm. So we have run K-means algorithm on this data set. So the true output should be this one, but as a result of the algorithm, we are getting this as the output, which is actually wrong. Okay, which is actually wrong. So here our K-means algorithm fails. Okay.
Yes.
So moving to the next slide. It's quiz time. Okay.
Sir, what type of algorithm we use when K-means algorithm fail?
Kernelized K-means, but that's not the part of the syllabus. Okay. And there are many more like fuzzy K-means, kernelized K-means. These are some advanced topic which are not very necessary as of now. Even I have also encountered this in my undergraduate degree. These are something part of a PhD or master thesis. It's like very advanced thing. But in real world, to be honest, K-means algorithm works perfectly well in real world scenarios. Okay. So 11 questions will be there, and they will be very like, first you have to answer them quickly, and then based on the leaderboard will be made. Okay. Those who are yet to join, please join as soon as possible. Yeah. Okay. Which of the following is an example of unsupervised learning? Grouping customer by purchasing behavior, predicting house price based on feature, classifying email as spam or not spam, identifying whether an image is a cat or dog. So in last two cases, we have labels provided, so it cannot be unsupervised. Correct. Grouping customer based on the purchasing behavior. So we have a data of the customers, and now we are grouping it because we don't have any levels provided to us, right? Okay, we means as a model. Think ourselves as model, we are grouping. Okay, next question. Read question very carefully. Which of the following is a binary classification? So binary means two, only two possible output. Identifying handwritten character, approving or rejecting a loan, labeling news article by topic, predicting academic grades. So only two possible output is possible where approving or rejecting a loan, because identifying handwritten characters, as I told, it's 0 to 9 in the MNIST dataset. News article can be anything, Bollywood, Hangama, anything, news article, sports, anything, tag. Predicting academic grades, we know A, B, C, D, E, more than two possible output, right? So yeah. Next question. Which of the following is regression? That is real value continuous output. Identifying spam mail, clustering together, or predicting house prices. So price of an house, or clustering segments, customer segments, or identifying spam mails. Correct. In a supervised learning, if you are building system to detect whether spam mail or not, what type of data you do need for training? Email contents without label, email with labels, or only the email address, email sender address? Supervised means label is necessary. Correct. In unsupervised, label is not necessary. Which of the ordinal, where order matters? Ordinal classification, predicting favorite color, categorizing product as electronics, or rating customer satisfaction as low, medium, or high? Where does our order matters? Correct. Low is lower than medium and high. Medium is lower than high and higher than low. and high is greater than low and median. Clustering is an example of which type of learning? Clustering, supervised, unsupervised, or sequential? How come so many people giving clustering as supervised? We don't have any level for clustering problems. That unsupervised, right? What does K in K-means represent? I already told you. What does K mean? Number of clusters or number of iteration or number of data points? I have mentioned it very specifically. Correct. Number of clusters. Okay. So 40 players are ready. 8th question. In K-means, how is the number of clusters determined? Automatically determined by algorithm specified by the user. I already told you the answer in the while discussing K-means. Based on the number of features on the data or based on the size of the data set. Who decide how many clusters we want at the end of the algorithm? User decide, right? My question. Which step is performed repeatedly in K-means clustering until convergence is achieved? Calculating Euclidean distance between data points and pivot, assigning data points to nearest center, updating cluster center based on, or all of the above. All the steps are required, right? Like pivot step, reassignment step, and for that we need to calculate distance. All of the above steps are required. What is the role of pivot in K-means clustering? What does pivot elements do? Represent center of the cluster, assign new data points to the cluster, calculate distance between the cluster, or label the data points. So label, I don't think so it's correct because it's unsupervised, right? So which one do you think is correct? To assign new data points to cluster or to represent center of the cluster? Correct. So usually the mean of the data points present there is the center of the cluster. We usually select it. Okay. And this is last one, I guess. Yeah, last one. So ready for the last quiz on your screen? And it is. Limitation of K-means with respect to the number of clusters. It automatically determines the optical number of cluster. No, it requires user to specify the number of cluster beforehand, or it produces non-spherical clusters. Very easy. Okay, it requires, as I told you, we as the user decide, we provide the data set and we decide how many clusters we want. Okay. So this is the leaderboard. Okay, so congratulations, Shantu, for being top in the leaderboard. Okay, so we are at the end of the session. It's almost 30 minutes past 6, I guess. Yeah, 6:25, 25 minutes past 6. You can give your honest feedback. Okay. In the next session, we'll discuss another type of clustering, right? Dendrograms and all. So yeah, that will be taken by my co-TA Prashasti.
Sir, can you please explain the Cartesian product again? I got disconnected that time.
So Cartesian plane is nothing but our x. We know x-axis and y-axis, right? XY plane, we know. Correct?
Yes,
2D
sir.
plane, XY plane, that's Cartesian plane. That's it. Okay.
Yes, sir.
So you can write your key takeaways from the session, whatever you have learned. And I would request all of you again to use the forum that I have shown you. Once you go to your dashboard, you will see that small forum action, forum icon present there, right? I think I have removed that one. Yeah, it is. Yeah, this icon, discussion forum. Just go and use that. Okay. Okay. So thank you for joining the session. It's already 6:30. 30 minutes past the deadline. So thank you all. We can close the session now.
Thank you, sir.
Okay, thank you, sir.
Thank you so much, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you so
Thank you,
much.
sir.
Thank you, sir.
Thank you, sir.
Oh.
यार मेरा मेरा है